Today we're going to see how to name ionic compounds. The last couple of days we've been talking about how to predict the formulas based on charges, and yesterday we talked about some of the properties of ionic compounds. Today we're going to learn how to name them. There is a process to naming these compounds. To begin with, let's just make a distinction between what are monatomic and what are polyatomic ions. We've started to see some of this in our work. Monatomic ions, these are simply a one-atom ion, and once again, as usual, you'll have to excuse the way that it's been reformatted here. So say, for instance, you had a magnesium atom that has turned into a magnesium ion. It's in family 2A, so it's +2. It's just one atom. Bromine, for example, by itself, neutral, but when it forms an ion, it gains an electron and it has a -1 charge to it. So a monatomic ion is just a one-atom ion. That's it. That's all there is to it. Okay, so mon meaning one. Okay, a polyatomic ion. We started talking about these yesterday in class, and hopefully you've done some work with them over the last few days. These are ions made up of more than one atom. The whole thing acts as an individual ion, so you don't get to break it apart. You're going to have multiple atoms, and you don't get to decide which ones you want and which ones you don't want. The whole thing acts as an ion. And the charge applies to the whole thing. So, for instance, an NO3 -1 charged ion, that is called a nitrate ion. And this charge right here applies to the whole ion. It doesn't apply just to the oxygen or just to the nitrogen. The whole ion has a -1 charge. It comes as one unit. So you don't get to break it up here. It comes as one unit. So refer to that yellow sheet that I gave you on Monday for some of these common polyatomic ions. They're also found in your textbook as well. If you need an extra yellow sheet, there should be some left in the classroom. Okay, so definitely want to have that on Friday for your quiz. So polyatomic ions, meaning you have more than one atom in that ion. The whole thing acts as an ion, as an individual ion, and the charge applies to the whole ion. Okay, how to name these polyatomic ions. There are, if you notice, a lot of these polyatomic ions have oxygen in them. A whole bunch of them contain oxygen. And so those are called oxyanions, and that is going to be any polyatomic ion that is composed of an element, usually a nonmetal, bonded to one or more oxygen atoms. Okay, so once again, get rid of this unformatted example. So we're talking about anything that is a polyatomic ion that contains oxygen in it. So PO4 -3, that is a phosphate ion. SO3 -2, that is a sulfite ion. Okay? So any polyatomic ion that contains oxygen and another, usually nonmetal. The rules for naming them are found below. It says you need to identify the ion with the greatest number of oxygen atoms. This ion is named using the root of the nonmetal and the suffix -ate. So take, for instance, what you see down below with the nitrate and nitrite. The formulas for these are NO3 with a -1 charge and NO2 with a -1 charge. And so you needed to identify the ion with the greatest number of oxygen atoms. Well, in this instance, that is the NO3 -1 ion. So you name it using the root of the nonmetal, which in this case is nitrogen, Nitr. Okay, and you change the suffix to -ate. So this becomes the nitrate ion. And whichever one has fewer oxygen atoms, you use the same root of the nonmetal, and the suffix becomes "ite." So this one over here is nitrite. Okay. If we look at, for instance, the SO4 -2 and SO3 -2 ions, notice they don't have the same number of oxygens as the nitrogens over there on the left side, the nitrate and nitrite. Nitrate has 3, nitrite has 2 oxygens, sulfate has 4, sulfite has 3. So the only connecting factor here is the fact that the one that's got more oxygen atoms, you take the root here, sulfur, change the suffix to -ate for the more oxygen one, so SO4 -2 is a sulfate ion. So yes, you do have those yellow sheets that have all the names listed out for you, but if you're trying to remember more easily, perhaps this is a good way of doing it. Okay, so sulfate, the one with more oxygen, ends in -ate. Sulfite, SO3 -2, has fewer oxygen. What about oxyanions that have 2 or more possible states? Okay, so if you look at your yellow-colored common ion sheet, a good example of this is the following: ClO4 -1, ClO3 -1, ClO2 -1, and ClO -1. Now here we have 4 different ions, all of which contain oxygen. So where do you start? Which one's the ate? Which one is the ite? Well, let's see here. The oxyanion with the greatest number of oxygen atoms is named using the prefix per and the root of the nonmetal and the suffix ate. So this one right here, ClO4 -1, that has the most oxygen in it. So it's going to have the prefix per, the root of the nonmetal, so chlorine here, chlor, and it ends with the suffix ate. So ClO4 -1, that is called a perchlorate ion. Okay, the oxyanion with the fewest oxygen atoms is named using the root of the nonmetal and the suffix ate, so 1 fewer. So this one right here, the ClO3 -1, basically all we've done is just drop off the prefix, and this is a chlorate ion. So that's the difference between perchlorate and chlorate. The oxyanion with 2 fewer oxygen atoms is named using the root of the nonmetal and the suffix ite. So here we're going to replace the ate with ite. So we're going to have chlorite ion, the chlorite ion, ClO2 -1. And lastly, the oxyanion with 3 fewer oxygen atoms is named using the prefix hypo, the root of the nonmetal, and the suffix ite. So the prefix hypo, the root chlor, suffix ite, that is the hypochlorite ion. Okay, so that's how they name polyatomic ions when you've got more than 2. That's how they do this. Okay, so as far as actually naming the compounds go, and this is where you're going to need to do the most practice, you want to name the cation first, that is to say the positively charged ion, followed by the negatively charged ion, that is called the anion. Okay, so that's the first one is the cation, that's the first part of the name. The second part of the name is the anion. If you have a monatomic cation, you use the element's name. Okay, so monatomic cation, these are going to be metals, typically metals. And all you do is just say the name of the metal to begin with. So sodium, lithium, potassium, calcium, magnesium, whatever it is, aluminum. Name that first, and you just say the name of the metal. That's what you start with. To name the monatomic anion, use the root of the element's name plus the suffix "ide." The root of the element's name plus the suffix "ide." Okay, and so this one you might have heard several times before, and this is just for monatomic. Just being clear here, monatomic cations and anions. If you have a monatomic anion, you take the root of the nonmetal, whatever it is. Let's say it's chlorine, Cl. Okay. The root is chlor, so CHLOR, and instead of ending in -ine, it ends in -ide, chloride. That would be a Cl -1 charge. Okay. Or bromine changes from BROMINE to bromide, BROMIDE, bromide. So if I had the example of a compound with the formula CSBr, which is what you see down there, we'd name that using the name of the metal first. That's the monatomic cation, cesium, and cesium is a Cs plus 1 charge. So you just say cesium. The monatomic anion is bromine that's become a bromide. So the name of that compound CSBr is cesium bromide. Okay. If you have a transition metal, you need to distinguish the different charges of the transition metals if necessary. So if you have a transition metal, you need to include its charge, because if you look at your periodic table, you would note that they can have multiple charges. Okay, so for instance, the compound FeCl2 is not the same thing as FeCl3. They behave very differently. Okay, they look very different. So you need to distinguish when naming these. You need to distinguish when naming these. So this one, for example, how you do that. Okay, let me change the color of the pen here. Right. FeCl2. Well, you still name it iron. Okay, and what goes in the parentheses is the charge on the iron atom. Well, how do you know that? You look at what it's bonded to. A chloride ion is -1 charge piece. You got 2 of them, so there's a total of -2 charge, which means that iron's got a +2 charge. So we indicate that with a 2 in Roman numerals in the parentheses following iron. And then you simply follow the rules from above. The monatomic anion, use the root plus the suffix "ide." So that would be iron 2 chloride. The 2 referring to the charge on the iron. The one that's right next to it is very similar, but instead of iron 2 chloride, okay, there are 3 -1 charges, so -3 total negative charge. The iron then has to be +3. So the name of this compound right here would be iron 3 chloride. Iron 3 chloride. So very similar in name except for that Roman numeral and charge. If the anion is polyatomic, you just simply give the name of the polyatomic ion. Okay, so if you've got, for instance, let's see here, NaNO3, okay, you name that by calling it sodium, that's the name of the metal, plus just name of the polyatomic ion. NO3 is nitrate, and you'd call that sodium nitrate. There you go. So just be sure you follow each of these rules. We're going to do several examples together here on the next slide. Okay, so let's do some naming here. The monatomic cation on the first one, NaBr, is sodium. And you have a monatomic anion, so the bromine changes its suffix to "ide." Sodium bromide. Okay. All right. We'll erase that so we can look at it more clearly. CaCl2. Okay. You've got a monatomic cation, so that's going to be just the name of the metal, calcium. And once again, you have a monatomic anion. It's 1 atom. So -2 total negative charge from the chlorine, so it's balanced. So we're going to call this one calcium chlor, and the ending changes from -ine to -ide. So that is calcium chloride. KOH, the K stands for potassium, so we just name the metal as our monatomic cation, potassium. OH, okay, if you check your yellow sheet of polyatomic ions. OH has a -1 charge. That is a hydroxide ion. And rule number 5 says just to name the polyatomic ions. That one's called potassium hydroxide. Okay. So this next one is Cu parentheses NO3 parentheses 2. Okay, so we name the monatomic cation first. That is copper. Okay, rule number 4 says to watch out for transition elements, so we need to see its charge. Well, a nitrate ion, if you check your table, each has a -1 charge. You got 2 of them, so that means that you've got a total of -2. The copper has to have a +2 charge, so we're going to include that as Roman numerals. And we finished it by just naming the name of the polyatomic ion, rule 5. Okay, so that one's called copper 2 nitrate. Alright, Ag2CrO4, let's rewrite that to make it look good. Ag2CrO4. You have a monatomic cation, silver. If you check your periodic table, silver can only have 1 charge. It can only have a +1 charge. So even though it's a transition metal, it only forms +1 charges. So therefore, we aren't going to need to put this in parentheses. Okay, we don't need to figure out the charge because we know it has to be +1. Okay, and now we just need to name the polyatomic anion, which in this case is a chromate ion. So the name of this compound is called silver chromate. My guess is that it would be a very yellow-colored compound. Chromate ions usually look yellow. And this last one, NH4ClO4. Okay, if you check your yellow sheet of common ions, ammonium is the very first one on the top left. It's NH4. So we're just going to name it starting with that, ammonium. And that ClO4 -1 ion is the perchlorate ion. So this is called ammonium perchlorate. Okay, that's what that's called. So those are some examples. What I'd like to do with you on that green sheet, the green worksheet, let's do a few sample problems together. Okay, so the first one that's given to you as an example says Cu plus 2 and ClO4 -1. Okay, let's see here. The name of that, the formula for that compound, well, we need 2 perchlorate ions for each copper ion. So our formula is going to be Cu parentheses ClO4 2. Okay, so to name it, we name the monatomic cation first. So we name that copper. We check our periodic tables. Yes, it can have multiple charges, so we have to name what charge it is. It's going to have a +2 charge. And we're given that up there in the problem anyways. And then we name the polyatomic anion, perchlorate. So that first one is named copper 2 perchlorate. Okay, so the first example you've got is Na plus and Cl minus. You need one of each of those ions for it to balance out. You have NaCl. Okay, so you've seen this many times, table salts. And to name it, we name the metal first, monatomic cation, sodium. And then we have a monatomic anion, so we take the root, chlor, change the ending to ide. The name of that is sodium chloride. Okay. We'll do one more together, and then the rest will be up to you. So the second one in that worksheet says Sn plus 2 and O minus 2. So looking at our charges here, we need only one of each of these ions. Our formula is SNO. Okay. And SN stands for 10. Okay. 10 is going to be on the periodic table. It's actually on one of the main group elements. However, it can have multiple charges. It can be +2 or +4. So we have to indicate what charge the 10 has. Well, 10 here has +2. You can see that from the ion. Okay, so we name that 10,2, and we take the root. We've got a monatomic anion. We take the root of oxygen, ox, and change it to oxide. So the name of that one is 10,2 oxide.